In the question, they give you focus. Figure 7.1 shows a converging lens or a convex lens and its principal axis, the imaginary line which is passing through a center. The point F are each a principal focus. On the figure, draw two rays from top of the object to locate the image of O and label that image as I. So how you will label this? So first we will draw a parallel light ray. If light ray is parallel to the principal axis, from where it will go? If it is parallel to principal axis, which point it will pass through? So it will pass through focus. So you can draw any length, a longer line, so that you can identify intersection. The second ray, it's up to you which one you take as a second ray. Example, I'm taking second ray passing through the center. So if it is passing through the center, it will pass straight. And the point, the position where these two light rays will intersect, the point or the position where the two light rays will intersect, that is a position where the image will form. And we have to label this image as I. Is it clear? Only two you need, but you can take the third one as well. If you took the I should start from the top, like the two rays should start from the same point. So I should start from here and then draw the straight line. The point where these two light rays intersect, that will be the position where the image will form. And we have to label this as I. Then underline three of the terms which describe the nature of image produced by a converging lens as magnifying glass. Not like this, a magnifying glass. Like when we use convex lens as a magnifying glass, what happened when we use this as a magnifying glass? So object is between the focus and optical center. The parallel light ray, it will pass through focus, and one through optical center will pass straight. The two light rays will not intersect. So when we look from other side, our brain relocate the position. So point where these two light rays intersect, that is the position where the image will form. This is what happened when we use convex lens as a magnifying glass. So what are the characteristics when we are using a magnifying glass? Number one, it's of 2 marks, so it's virtual. Virtual is there. And it is upright as well. Upright means like same as like object. And it is enlarged or magnified. So 3 terms: virtual, upright, and enlarged. Because you have to underline 3 terms. And what is the distribution of the marks? Means if you did 2 right, you will get 1 mark. If you did all correct, you will get 2 marks. Because in IGCSE, there is no half mark. Like it will not be 0.66 marks for each answer. Either always whole numbers are there in IGCSE. So if you get 2 right answers, you will get 1 mark. If you get all 3 right answers, you will get 2 marks. If you did get 1 right answer, then you will get no marks for that. Because there is no half marks in IGCSE. The diagram shows a path of a ray of a red light which is passing through. So this is a red light. A ray of a green light enter a prism. So if a green light enter a prism, if this was a red light, red is having a longer wavelength, so it bend least. If there was a green light coming from the same point, so it will bend more. This will be the path. If they say for violet, again further, it will further bend away from the normal. Figure 7.1 is a diagram of a converging lens used to produce image of an object. Each point marked F is a principal focus. Write down 3 terms, describe the image. Means what are the characteristics of this image? Inverted, that's one. No, it's not virtual, it is real. Why it is real? Because what happened? When the two light rays, you will draw the light rays. When it passes through the lens, the two light rays will converge at one point. So when the two light rays converge at one point, the image form is real. So it is real. And what else? It is a real image. That's one thing. And it is inverted or upside down. And when you compare the size, no, not same distance. This is not a mirror. Same distance is not, you can measure on this. You can measure the distance here. You will find it's not same. It's different. You can see the size of image is bigger, larger as compared to size of object. So the 3 characteristics of this image, it is inverted, it is real, and it is enlarged or bigger than the object. Figure 7.2 shows a plane mirror. A point O is an object and observer eyes. On the figure, draw 2 rays to show the reflection to the observer eye, and then complete the figure to draw the position of image. So what happened? The 2 light rays will reflect from the mirror. So the 2 light rays, when it hits the mirror, it will bounce back or it will reflect. So what happened? What happened? We cannot see the image here. So our brain sense the light is coming straight from the object. So when our brain relocate, we'll get the image at this point. But how to do this question related to, how to do a question related to this? So always the object distance and image distance for a mirror is same. So best way to do this question, what you will do, because what is happening, the light rays from the object hit the mirror, reflect or bounce back, and when our brain relocate, our brain produce them backward, so our brain produce an image. So if you have an object, as we know for a plane mirror, the object distance and image distance is always same. So what you will do, you will measure the distance between the object and the mirror. Example, if this is 2 centimeter. So this is 2 centimeter, then Measure 2 centimeter and draw the position or mention the position of image. First thing, that is the position of image. Now what you will do after getting a position of image, so this is the example, this was image. So you can draw the rays directly from image to the eye. You can draw the rays directly from image to eye and then join these rays from object to the mirror. So in short, like in a short time, you can just complete the figure. So what happened? The two light rays from the object hit the mirror, bounce back or reflect, enter our eye. When our brain relocate, we'll get the image. So best way to do these type of questions, measure the distance between the object and the mirror, and then draw or mention the position of image. Draw the two light rays. Draw the two light rays from the image to the eye, from the image to the eye, and then complete these rays by joining on the mirror. So this is in a short time you can complete your answer. The only thing what you have to do, you just have to measure a distance between the object and the mirror and then just make another distance from mirror to the image. Is it clear? Any doubt in this? Figure 7.1 shows a converging lens and a principal focus. F1 and F2 are there. On a figure, draw two rays from top of object to locate the image. So as you can see, the object is within the focus, so it will be in virtual image. So parallel light ray, from where it will pass if a light ray is parallel? So it will pass through F2 and one through the center, it will pass straight. The two light rays will not intersect by themselves. So when we are observing from other end, our brain relocate or create a position. So the point where these two light rays will intersect, that is the position for the image. This image is virtual, it is upright, magnified, same side as object. In the next question, the object O move to the left, like this was object O, it's moved to the left of F1. The object is moved on the left. Figure 7.2 is a diagram for new arrangement. Underline three terms, describe this image now in 7.2. What are the three terms which we should underline? This image is real, that's one thing. According to this question, it is real and it is inverted. And when you compare size of object with size of image, it is enlarged. Diminish means small in size, enlarge means greater in size. A laser produces a beam of monochromatic light. Monochromatic means light with a single. What is meant by a term monochromatic? It means light with single wavelength. or light which is having only one wavelength, we call that as monochromatic. A single color, scientific definition, if you say single color, scientifically, color is not a right term. That's why specifically wavelength or frequency is used. Then a figure, a wave in air incident or hit the glass, a wave undergo reflection and refraction. We have to complete this. So if you want to show reflection, these are the wavefront. So the wave which strike and it will bounce back. This is the direction in which the wave will bounce back. So moving from air to, like, this is reflection, and how we show the reflected wave fronts. So we just draw wavefront perpendicular or 90° to the direction of the wave. This is reflection. And how we show refraction? Refraction means when when the wave travels from one medium to another. So when the light travels from one air to glass, it will bend towards the normal. So when I draw the normal here, if I draw this yellow line is representing a normal. So it will bend towards the normal. And how we show a refracted ray? Because when it moves from, so when it travels from air to glass, it slows down. As the wave slow down, its wavelength decreases. So wavefronts will come closer to each other. So these wavefronts, as it slow down, so these wavefronts will be closer to each other. Is it clear? This is the figure which in terms of wavefront you have to complete. So in reflection, the direction only changes, but the distance between the wavefront remains same. But moving from air to glass, the air light slow down. So as it slow down, the wavelength decreases. That's why the wavefronts will come closer. Figure 7.1 shows a convex lens used to produce an image. Place 3 ticks in the table to describe the image. What is this image? Diminish. This is enlarge, upright, and virtual. On a figure, mark a letter E, indicate the I. Where we should place I? On the left hand side or on the right hand side? Which position I should place an I? Here, on the left or right?
Left.
It should be here on the right hand side. Because that's how, when you're looking from here, your brain recreate the position. So that's how you recreate.
Yeah.
It is on the right hand side. You don't have to draw the eye, you just have to mention. And this image cannot be taken on screen because it's a virtual image. State an application in which convex lens is used. So we use this as a magnifying. No, not projector. Projector is used for enlargement, but it is a real image. This is a virtual image, so it is used as a magnifier or magnifying glass. So this question, in a space below, draw a diagram to locate the image of an object, height 1 centimeter and place 5 centimeter of focal length 2 centimeter. We did this type of question, so you can solve this one as we practiced.
Yeah.
The height is given, focal length is given. So you can draw this. Now, on a figure, draw a reflected ray. So when you are showing a reflection through a mirror, the best way what you can do, just measure the distance between the object and the mirror and locate the position of image. And the two rays you will draw from image. And just make an eye. This is how the light rays, actually what happened, light rays reflected from the mirror enter our eye, our brain recreate or locate the position, so it make a virtual image. Eye is the image which is formed by the imagination of the brain. O is the object. What happened? The two light rays coming out from the object reflected from the mirror, and as these light rays reflected from the mirror, it will follow law of reflection, so it enter our eye. When these rays enter our eye, our brain recreate the position, the point where these two light rays appear to intersect. That is a position where we'll observe the image. So in reality, it's not there. It's just our brain recreate. We call that as imaginary.
But this is a reflection.
Which one? Yes, so yeah, this is a reflection. A light reflected from the mirror enter our eye,
we'll
and
see it inside.
So we'll see, like if you're standing in front of a plane mirror, you observe that all the things are back of the plane mirror. In reality, nothing is back of the plane mirror. It's just a virtual image, imagination.
Yeah, got it.
So state the full description of image. What is this image? What are the characters?
Image.
Enlarged, virtual, and upright. Full description, so you have to mention all the points here.
Virtual.
Use a letter on a figure, indicate the focal length. Where is the focal length?
R.
Which position? P, Q, R, S. Where is the focal length?
S.
S is the focal length because when parallel light ray always pass through focal length. So S is the focal length.
Yes.
On a figure, draw an eye. So where we'll draw an eye? We'll draw eye at this point. Figure 7.1 shows an object left of the converging lens. Draw two rays to locate. So first parallel, from where it will pass?
F, focal length.
So it will pass through the focus, one through the center. It will pass straight. The point where the two light rays will intersect, that will be the image. For example, if in a question you have, they give you object and they give you image and they ask locate the position of the lens. So how you can locate the position of the lens? So in that case, if object is given and image is also given and the question is locate the position of the lens. So how to look
straight line from the top.
Yeah, so how to locate the position of the lens? Actually, you will draw a line from tip of the object to the tip of image. Yes. The point where this will intersect the principal axis, that is the position of the lens. Because the light which is passing through the center of the lens does not refract. So if some question they ask this, like stay or identify position of the lens. So you can identify just by drawing a ray of a light from tip of the object to the tip of image. So these are some questions related to topic light. Others are actually paper 6 question that we'll discuss in paper 6. This was about paper 2 and 4. So I'll end the session and share this recording with you.